All right, I'm going to go through some of these on proving trigonometric identities. You're going to have a lot of different kinds of proving identities, and it's a little difficult to explain because there's a lot of different ways you can do these and still come up with a correct answer. So I'm just going to work through some of these. Over on the right-hand side, I have my regular identities all listed there. You'll have some more later as you go on. But if I look at this first one, I have the sine of x times 1 plus the cotangent squared of x, and I want to end it up equaling the cosecant of x. Whenever I see the squared one in there, I look for one of my Pythagorean identities, and you'll notice over here on the side that the cotangent squared plus 1 is equal to the cosecant squared of x. So that's the one that I probably want to use, because I'm trying to end up with the cosecant squared of x. So I'm going to go ahead and in this here, I'm going to leave the sine of x alone. I am going to change the 1 plus cotangent squared into cosecant squared. And then I have to select my rule. That would be my Pythagorean identity. I'm going to hit validate there. Then I'm going to look at that and I say, okay, I still want to change it into the cosecant. So if I look at my sine properties up here on my reciprocal identity, you can see that the sine of u is equal to 1 over the cosecant. So that's the one I'm going to use to change my sine into cosecant. So I'm going to do 1 over the cosecant, and this is of x since that's the variable I'm using, times parenthesis cosecant squared of x close my parenthesis there, and the rule that I used was the reciprocal identity. So I am going to select my reciprocal identity and validate that. Now on the next part, all I'm going to do is cancel, and so I'm just using plain old algebra. Sometimes that's just my rule, it's not one of my identities, but I'm going to cancel out the cosecants, and when I cancel out the cosecants, I'm going to end up just with the cosecant of x, which is what I want. And my rule there is just that I did algebra. And so I'm going to select algebra, I'm going to validate, and my proof is complete. So I'm going to go ahead and hit check and go to more practice. Okay, so I have 1 plus tangent squared times cotangent squared equals cosecant squared of x. I'm again going to look at the part in the parentheses. When I have the 1 plus something, that's usually one of my Pythagorean identities, which in this case, the tangent squared plus 1 is equal to the secant squared. So I'm going to go ahead and put secant squared of x in for the 1 plus tangent squared of x. So secant squared of x. Don't really need the parentheses, but I could have put the parentheses around that. It's not letting me do it, so maybe I better put the parentheses around that. There we go. Times cotangent of x, or cotangent squared of x. So now I'm looking at that and saying, okay, I'm trying to get to the cosecant squared of x. I've got that cotangent squared. So I'm going to look at what kind of things I can change the cotangent into. The cotangent is 1 over the tangent. That really doesn't do much for me. But I see that the cotangent is the cosine over the sine. And then if I go down farther, I also see that I could have the cotangent, if I rearrange it, be cosecant squared minus 1. And I think there, if I look at that, I think, oh, if I did the cosecant squared minus 1, I'd have to use the distributive property. So I look at it and think, well, maybe if I just change them into terms of sine and cosine, then I'll be able to change it into cosecant. So what I'm going to do there is change my cotangent, since it's squared, into cosine squared over sine squared. So, whoops, I didn't select my rule for this one. That was my Pythagorean identity. So for now, I'm going to leave the secant squared of x because they don't like me to do too many things at one time. Sometimes they let you do it, and sometimes they don't, so I just take extra steps if I need to. And so now I'm going to change my cotangent squared into cosine squared over sine squared. If all else fails, try to change them into sine and cosine and then work from there. Whoops, I didn't want to do that one. I want to do my fraction over here. So let me just type cosine squared. Oops. Sometimes it's trickier to get them typed in how you want them than anything else. And so what I did there is I used that quotient identity, which is just in the plain cotangent, but because it was cotangent squared, then I also had to make it cosine squared over sine squared. So that's my quotient identity. Got to validate that. So since I changed this into terms of sine and cosine, I'm going to change my secant squared into terms of sine and cosine. I'm going to use my reciprocal identity. Again, because this is in squared, the secant squared is equal to 1 over the cosine squared. So I'm going to do 1 over the cosine squared. And then I'm still going to have the cosine squared times the sine, or over the sine squared. And I use my reciprocal identity there because I changed my secant into 1 over cosine, or secant squared into 1 over cosine squared. So that's my reciprocal identity. The next step is just going to be plain old algebra. If you notice here, you can cancel out the cosine squared of x. So if you do your canceling on the cosine squared, you get 1 over sine squared. And that's just algebra. And then last thing I look, I see I have 1 over sine squared. If you notice in your reciprocal identities, 1 over sine squared is equal to the cosecant. So, or 1 over sine is equal to the cosecant. So 1 over sine squared would equal the cosecant squared. And that is my reciprocal identity again. And now I have my proof done. So sometimes when you get stuck, go ahead and just try to switch things into terms of sine and cosine and see if that works out for you. Doesn't always work, but it is one that works quite often if you get stuck and you can't figure out, well, what should I do? Just change everything into terms of sine and cosine and see if you can cancel. And then remember, on your reciprocal identities and quotient identities, you can also put them in terms of squared instead of just the plain identities, which is what they normally have there. I gotta hit check here. And I'll work through one more here. So we have 1 minus sine squared of x equals cosecant squared, or cosecant of x. We want to turn it into cosine and cotangent. In this case, I see I have 1 minus sine squared. Again, when I have that in the parentheses like that, I always think of my reciprocal identity. And you'll notice that we have the sine squared plus the cosine squared equals 1. If I rearrange that and move the sine squared to the other side, I'm going to have 1 minus the sine squared equals the cosine squared. So my first step there is I'm going to change that into cosine squared. Cosine squared of x times, of course, the cosecant of x, which is already there. And that is my Pythagorean identity. Okay, now that I have it in terms of that, I'm going to go ahead and change my cosecant. If I'm looking at my cosecant is equal to the 1 over the sine. So I'm going to go ahead and change it into 1 over sine because, again, I'm going to change it into terms of sine and cosine if I'm looking for what I'm doing. Whoops, I didn't want that in there and I didn't validate. I better validate here. So I'm going to leave the cosine squared. And then I'm going to change my cosecant into 1 over sine. Oops. This doesn't want me to get out of my thing. If I get stuck on those, I just usually stick some parentheses around it, and that usually helps me when I'm trying to get it typed in. Now let's see if it'll let me do it. Nope. Here we go. Nope. Gosh, it just doesn't want me to get out of there. Well, let me hit the next set of parentheses then. That will work. 1 over the sine. So if you get stuck trying to get it typed in, just put parentheses around your expression. Sometimes it's tricky. It doesn't like you to type. Okay, so now I have that written as 1 over sine. And so when I select my rule here, that was my reciprocal identity that I just used. So here's what I have. I have the cosine squared of x and 1 over the sine of x. If I split this up, I can write this as cosine over sine, and cosine over sine happens to change in the to the cotangent. So I didn't validate again. I'm going to just break it up. So I'm going to have the cosine of x plain by itself, and then I'm going to have the cosine of x over the sine of x. Whoops, again, it's just a pain to get them typed in sometimes. And that was just basically algebra. I divided up my cosine squared into cosine and cosine so I could have cosine over sine. And so that I can change that into cotangent. Cosine over sine is my cotangent, which is one of my quotient identities over here. And so I'm going to leave the cosine of x, which I wanted. I'm going to change the cosine over sine into cotangent of x. And that was my quotient identity. The cotangent is equal to the cosine over the sine. And so I'm going to say quotient identity there. I'm going to validate that. My proof is complete. So again, if you get stuck, try to change them into terms of sine and cosine. See if that helps in solving these.